Today we're going to talk about DICOM association. Every time a text sends an image to PAX, it starts with a DICOM association. Every time a doctor pulls up images to look at, it starts with a DICOM association. All DICOM data retrievals and searches are built from DICOM associations. There are protocols. When two DICOM devices want to connect, there are standard protocols for how they make the connection. The main goal of DICOM association protocols is to ensure that two communicating DICOM applications are compatible and transfer data in a well-defined format and order. DICOM connections are built upon the basic TCP/IP connections all computers make to exchange data. However, unlike TCP/IP, DICOM connections make decisions about what transfer format will be used and include information about what each device's capabilities are. And it all starts with a handshake. Kind of like two people meeting for the first time, right? There's a protocol when you meet somebody in a business setting. You do a handshake. DICOM devices have a DICOM handshake. When two DICOM devices meet to make a connection, the first thing they do is exchange information about their functionality and communication parameters. If they were humans, the conversation might go something like this. The MR scanner to the archive. Hi, I'm an MR scanner and I speak DICOM. Do you? The archive might respond with, Hi, I'm an archive. I speak DICOM also. The MR scanner. Are you an SDP for MR image storage? Which that question means, can you store MR images? The archive would say, sure I can. And the MR machine would say, listen, I got 100 new uncompressed MR images and I want to send them to you as is, but I can also send them compressed with JPEG 2000 or compressed with 12-bit lossless JPEG. You know, how would you like them? And the archive would say, no problem, I can take your MR images, but I prefer them uncompressed. MR would say, okay, starting to send. Archive would say, okay, ready to receive. So keep in mind how chatty that is. That's just to make the connection and to figure out what format they're going to send them in. So a lot of times people will click to download an image or click to open up an image in the PAX system, and they have a hard time understanding why it takes so long. Okay? When you click on, a link in a web browser, it's only doing TCP/IP, and it just takes you to that server or takes you to that location and it opens up right there. Here in DICOM, we're transferring the images from one place to another, and you have this really chatty conversation going on back and forth, and that just makes for the whole transfer process to be slow. Presentation context. The information shared at the DICOM handshake is called the presentation context. It's like the device's business card listing who it is, what it does, and what data formats it can use. The presentation context information has two parts. There are the essential part and the negotiable part. The essential part, called abstract sequence, abstract syntax, not sequence, abstract syntax, represents the functions of the device. In other words, it's what the device can do. So if we look back at our conversation, right, this first part here, I am an MR scanner and I speak DICOM, I'm an archive, that is the abstract syntax. And that part can't be changed because the MR scanner is always the MR scanner and the archive is always the archive. Right? So that's the essential part or abstract sequence that represents the functions of the device, and it can't be changed. The negotiable part, called the transfer syntax, represents all the different formats the device can package the data in to be transferred. Most devices can use several formats, so this part that can be changed to find a common format between the two devices is called the negotiable part or the transfer syntax. And here you see the transfer syntax, right? I have these images and I can send them with this compression or with this compression, in that format. And then it says, no, I want them uncompressed. That is the transfer syntax. So how this all gets started, how these two DICOM devices meet. When a device wants to make a DICOM connection, the first thing it does is build a message that contains its presentation context and user information. And in this context, the term user information refers to information about the requesting device. It has nothing to do with any human users. It's just the device's information. The message it assembles and sends is called an associate RQ or request message. It sends the message to the device it hopes to connect with. Sometimes associations get rejected. This is kind of like dating. When a device receives an associate request message, it reviews the presentation context information to see if it matches the functionality requested and if it has a matching transfer syntax. If they are compatible, the association request will be accepted. To accept the request, the receiving device would send a message called an associate AC or accept message. On the other hand, if the device doesn't match the functionality requested or doesn't have a compatible data format, it will reject the association request by sending an associate RJ or reject message. Finally, if the device experiences a problem, it can terminate the association using an abort message. This is very rare. It usually only happens after an association has been made. When an application entity receives a request for association, it will either accept or reject the request for association. Once the abstract syntax or the roles of the two devices is established, then the two applications have to agree on the transfer syntax. This is the negotiable portion of the connection. All DICOM devices must be able to read and write Little Endian. And there are two versions of Little Endian. They are implicit and explicit. Implicit Little Endian is the basic DICOM default transfer syntax. Little Endian is just, hey, I have these images and I want to give them to you in one of these formats, and the archive or whatever's on the other end says, yes, I'll take them, I want them in Little Endian. That's implicit. Explicit Little Endian is the same as implicit, but it includes the VR type in the DICOM object data. Remember, VR stands for value representation, and it includes more information and data types about the types of images being sent. For example, the VR type would include the AE, the application entity title. And so where you might want to use this is, let's say you have images coming from the CT scanner in the emergency department, and you want those images to be routed back to certain stations and back to a particular radiologist who is just dedicated to reading stat studies from the ER. Well, you could use the VR type included in the DICOM object to say, if you get a study from Hack ERCT, send that to the ER radiologist. That's how that magic happens. But to make that work, the transfer has to happen in explicit Little Endian. If it's done in implicit Little Endian, it's not going to work. The other common data type included in association requests is explicit Big Endian, and it's the same as explicit Little Endian, except Big Endian is read the other way. Right? So that's the difference between Little Endian and Big Endian. Finally, part of the transfer syntax is the application context. The application context element in association requests could contain information about the application entity manufacturer and can also be used to enable proprietary data transfer protocols. For example, if you had a GE ultrasound card and a GE centricity PACS, the application context element could be used to let both entities know that they are both GE systems, and then they can use GE specific language to transfer image measurements instead of using DICOM. Instead of using just the pure DICOM, they can go, hey, we can go off in the corner by ourselves and use our own GE proprietary language to move this from the ultrasound card to the PACS. However, most application entities use the DICOM default value of 1.2.840.10,000 and 8.3.1.1.1 in the application context field. That is the default value that just says, hey, just use regular DICOM. We're not going to do any proprietary languages. Okay, thank you for watching.